Okay. So here's our solution set for the case gamma greater than 2 squared or Km. Okay? Now, if gamma is close to 2 squared or Km, then what does that do to your solutions? Well, you looked at it for a minute and you were thinking, so well, what if it's equal to 2 squared or Km? Because if it's a little bit, if it's close to this, it's close to being equal, right? So what happens if it's equal to 2 squared or Km? Well, you saw immediately, well, that's what makes the square root, the discriminant, the thing under the radical here, 0. And you can just do that by substituting, but in the context of what we've been doing, we know that that's what's going to happen, right? Still, you know, if you're out there in the ozone and haven't thought through the development and everything, you can easily plug this in for gamma and verify that it's both of these solutions are going to be the same, right? Okay? So if gamma is close to 2 square root of Km, then these two functions have to be close to each other. Because gamma is close to 2 square root of Km, both of these square roots are going to be of small numbers. Okay? So you're not going to have much difference between negative gamma over 2m plus this and negative gamma over 2m minus this, right? Okay, well, which one of these are both decreasing exponentials because we know that the factor up here in front of t is always negative, right? So we know we have decreasing exponentials. So let's just say here's one of them. Okay? Which one is going to decrease faster?
The one on the right?
Yeah. Because the two negatives add up to a negative with a bigger absolute value, right? Which is going to make the exponent here, the negative exponent here, it's going to be 1 over a bigger exponent for given t. Okay? For all kinds of, okay? So we can say whether this is close to or far from 2 square root of Km. Okay. This one has the I don't want to use K, I don't want to use R, I don't want to use lambda. Just invoke Laplace transforms for a minute, but e to the negative st decreases more quickly for greater s. Because for a given t, you're going to have a negative of a bigger number, which means you're going to have the reciprocal of e to a bigger number. Okay? So it's kind of like 1 over st is less if t is greater, okay, or if st is greater. For given t, a bigger s will give you a bigger denominator here, which will go into 1 fewer times, right? Okay, so we got this thing. So we're going to have 2 of these, okay? And one of them is going to decrease a little faster than the other. Use 2 different, I'll just go ahead and use the yellow. Okay? So this would be your first solution, this would be your second. Now, your solution is going to be a linear combination of these 2. Okay? So you can take as much of this one as you need and as much of this one as you need and fit your initial conditions. And that'd be like an initial condition on the original value of the function and the original derivative of the function. I give you two simultaneous equations. You've got a linear combination like a C1 times this and a C2 times this. You can solve for C1 and C2. Okay?
So find the right vertical shifts to fit.
Well, each of these would have a vertical stretch, not a shift.
Yeah.
You don't get the shift. They're not exponential functions anymore. Okay? They're asymptotes, not the axis anymore. Change the asymptote if you vertically shift them. You can horizontally shift them, but really, you just need to vertically stretch them. Okay? Another way to understand this, incidentally, is you got a greater factor of t here than you have here. Have a factor of greater absolute value, which horizontally compresses the e to the negative t function more. If it's horizontally compressed more, well, that one's horizontally compressed more than this one, right? Okay? Many ways to understand that. And if gamma is far from two square root of km, then you have this. Of course, this is the one that I'm doing in yellow. Okay? Makes sense? So then you get to essentially vertically stretch each one of these. And by vertical stretch, I also mean a vertical compression. I don't like to use the two terms because you say vertical compression by 1/2. I just like to say vertical stretch by factor 1/2.
Yeah.
Or I came up with a different set of words. But anyhow, I'm not going to try to think of those words. My pre-calculus class doesn't meet for a little while. I'll have to think of it before then. It's pretty brilliant, so I'm pretty proud of it. Okay. Anyhow, does that make sense?
So would those be fundamentally different? It seems like they should be.
Yeah, but when you add them, you don't get an exponential function. You can't add these and tell me, okay, this is e to the qt for some value, single value of q. Okay?
Okay.
It isn't. And you can prove that, so you ought to. You probably don't have time. Still.